My name is Billy Schuler, and today I will be taking you through the experiment known as Golden Rain. Before we start, let's talk about a few topics that are important to know if we are to fully understand what is happening in this experiment. The first topic we will talk about is a double displacement reaction that we will see in our experiment. A double displacement reaction occurs when two ionic compounds dissociate in an aqueous solution and the respective ions bond with the cations and anions of the other compound. The ions basically switch partners. When this happens, two new compounds are formed from the existing ions, and when this happens, a precipitate may form. This leads us to our second topic, precipitation reactions. The precipitation reaction that occurs to produce golden rain happens when after a double displacement reaction takes place, one of the two resulting compounds forms an insoluble ionic solid called a precipitate. Now let's look at the actual equation from our experiment. We can see from this that the states of matter written after each compound, in this case PbI2 or lead iodide, forms a solid. So why does this precipitate form? Let's look at our solubility rules. The solubility of ionic compounds in aqueous solutions varies greatly. A set of rules that help us determine if a compound is soluble is listed in the table here. Rule 3 clearly states that I, or iodine, is soluble except when paired with Pb, or lead, like we see in our experiment. Lead iodide is only very slightly soluble at room temperature. Now that we have this background info, let's look at our experiment equation again. 2 moles of potassium iodide mixes with 1 mole of lead nitrate to form 2 moles of potassium nitrate and 1 mole of lead iodide. The equipment needed for this experiment is 1 gram of potassium iodide, 0.8 grams of lead nitrate, 500 milliliters of distilled water, 3 flasks, and either a hot plate to heat the solution or hot water to add to cause the precipitate to dissociate. There are a couple precautions we should take before conducting this experiment. The first one being that lead compounds, especially soluble lead compounds like lead nitrate, are very toxic. We should also follow our safety standard procedures, including wearing your safety goggles, apron, and gloves at all times. Without further ado, here is the video of our experiment. Now that we've seen the experiment conducted, let's look at our net ionic equation and focus on the ions that form the precipitate and make up the golden rain in the experiment. Here we see that our original equation is broken down into all of its ions. The precipitate forms, the spectator ions are canceled out, and we are left with what we need. Now let's determine the solubility of lead iodide. Here we have our net ionic equation, which is 1 mole of lead plus 2 moles of iodine formed to make 1 mole of lead iodide. Now let's determine the solubility of lead iodide. We can do this by using the net ionic equation to form an ICE table and using the KSP, which is the solubility product constant, to find the solubility. When solving for X, we find that the molar solubility is 0.00152, and multiplying by the molar mass, we find that the solubility in grams per liter is 0.699. With heat, the solubility actually increases by almost 6 times to 4.1 grams per liter at 100 degrees Celsius. As we saw from our experiment video, lead iodide only dissociates at higher temperatures. The increase in kinetic energy that comes from higher temperatures allows the solvent molecules to more effectively break apart the solute molecules that are held together by intermolecular attractions. At high temperatures, the reaction shifts to the left and the solution becomes colorless. As the solution cools, the equation shifts back to the right, slowly forming crystalline precipitate, which are more dense than the solution, causing them to slowly fall to the bottom of the flask. Here's a quick overview of the entire experiment. I hope you enjoyed the video, and you should now have both a thorough understanding of how to perform the golden rain experiment and what exactly is happening based on the topics we have learned in class. Thank you.